Hi everyone, I am Kalyan Prasad. It's really so pleasure to be here in JupyterCon. So today I'm going to talk about advanced visualization in Jupyter notebooks. In this talk, we are going to look at some advanced ways to visualize our data. So before jumping into the content, let me quickly introduce about myself. I'm a self-taught data scientist and I also love to involve in tech communities. Currently, I am a core member of Hyderabad Python user group and also the organizing committee member of PyCon Hyderabad. My areas of interest are in AI and fintech. So here is the agenda for today's talk. We'll start with advanced visualization overview. Data visualization is a huge field. You can see that just by looking at various matplotlib examples on their website. Now, some of the key things to take away from this field without becoming an expert in data visualization are it's a delicate skill. So you have to be careful and not to exaggerate, even though you have so many tools at your disposal. Sometimes using less is more. On the other hand, don't underestimate your audience. It is important to show various insight from our graphic. So we shouldn't just assume that the average reader of our document or a person who is going to look at our analysis report would be able to understand the concepts we are describing. Instead, we should try to teach the audience how to read the more advanced graph and don't underestimate them. I like to think visualization as a way of storytelling. So think about what motivation of your research or work is and basically how to use these plots to guide the reader to understand the concepts you have discovered during your data analysis. Introduction to Information Dense Visualization. A key person in data visualization theory is Edward Tufte. He has really mastered the skills and written multiple books. On the same matter, I would highly recommend his book, The Visual Display of Quantitative Information, which is the prime source that really combined all of the important concepts here. One of the important concepts he mentioned in his book is information density. So think of this way. If we have a pie chart like this, which basically shows the size of four items, would it be better if we would replace this pie chart by four numbers? The pie chart uses here a lot of colors, lot of shadows, lot of effects here. At the end, it just conveys the information about four numbers. So I think it would have been better to use a table in this case or just describe the numbers in text. One of the graphics Tufte used in his book is Napoleon's March, which was created by Charles Joseph Maynard. So this graph basically shows the port of Napoleon's army losses in the Russian campaign of 1812. So this is the graph. It looked quite complex at first sight, but if we break it down, the brown area shows the position of the army and size of the army as it advanced towards Moscow. And basically, if we look at x-axis, it shows both the geographical movement and passage of time. The black color shows the retreat of the army after their loss, and we can see so many variables on this graph. This is called multivariate visualization. We can see the army size and its location over time. And if we look at the small graph on the bottom, we can see the temperature that related to army's retreat. So we can see the temperature that is really getting cold towards the end of retreat phase. This is an example of information dense graphic which shows many aspects and basically tells a story in and of itself, which makes it a masterpiece of data visualization. Now, what sort of graphics we are going to deal with? I'll be quickly showing them once we cover the remaining concepts. Visual data correlation. The objective of this topic is to compare different methods of two data variables. So if we are talking about time series data, the first thing would be visual comparison and to understand the properties to compare. So here is a sample time series example. It splits the first plot already. Here you can see the original. And if we look at the second plot, we can already see the seasonal effect or seasonality change. So these are certain patterns, and we call these seasonal patterns if they are repeating over time. And then what we have is called a trend line or a trend change, which is the third plot in this visualization. So what I want to conclude finally here is if we are plotting time series side by side, one thing is to look at their properties and then compare by it. The method which we are going to describe, which basically shows trend more clearly, is known as moving average method, which will be showing in the Jupyter notebook. And the second plot, which has a similarity between the data and the relationship, is scatter plot, which basically plot two variables, one on each axis. So here is a sample example of income and education of scatter plot. Basically, the data point shows for each data point a person with particular education length in years and what their income is. The scatter plot, what shows here is called correlation. Correlation is a statistical measure of association or dependence. You can think of correlation visually. So here are the different plots of data and their correlation value. A perfect correlation of one would be the linear function, which is the first example in this plot. If we look at the correlation with 0.8, where we can see a scatter plot, but we can also see some sort of direction, and there is like there is a messy points, and we can also see a variance of data outlier and so on. If we jump to the correlation with 0 here, there we can see that there is a circle of messy point, and it clearly says that there is no relationship between variables in this scatter plot. So one thing that usually mentioned in relation to correlation is correlation does not imply causation. It means if two variables are correlated, it doesn't mean that one affects the other or vice versa. And then what we have is called the linear regression. So it is a method for fitting a simple mathematical model to our data. The function which we are going to using for fitting a model is a linear one, which is f of x is equal to ax plus b. So if we show this graphically, it shows that as it describes the data behavior by plotting a straight line which follows the direction of scatter plot. This is a simple example, but it would be a typical use case which is used in science, which is to model real world behavior on experimental data. So we collect the data in reality and we try to model, and to describe it, we use some mathematical functions, we evaluate the results, and we calculate the errors and so on. So this is a small step into the direction of actually doing the science of data science part. Now what we have is we'll be quickly showing the demo of the concept what all we have covered so far. So I'm taking Chicago crime and weather data sets here. Then we'll analyze these two data sets here, and then we'll show our graphics accordingly, and finally we'll show to how we can build a simple linear model on the same. Let me jump to my Jupyter notebooks here. So I've already created the Jupyter notebook and also executed the code as well in order to save the time. For this demonstration purpose, I'm just considering only the one period of data from both dataset, which is 2016. So I've already imported the packages and I've read the both data sets here. So the thing which now we are doing is we are plotting the data side by side. So from temperature data, we are calculating resampling by day and calculating the mean. Now you can see the day-wise temperature data, where we can also see the seasonal effect here. So I did the same for crime as well. You can see the number of crime instances. Now we are plotting these two data sets on the same graph. So if you observe here, these two are different data types and the values are nowhere related to each other. If you look at the temperature value, it's in the range of 10 to 20, whereas the crime rate values are in the range of 600 to 800. So what shall we do in this case? In theory, we could have added another y-axis and basically have both plots on the same graph with a different y-axis. But that's a bad practice in data visualization. Instead, we could create a two subfigures here, and for each subfigure, what we can do is we'll pass this fixed size and with and other matplotlib properties like title and then. So if we plot now, we can clearly see that which data set belongs to which graph, and it clearly says that temperature and crimes are one next to each other. And the thing which I mentioned in this slides is we are trying smoothing our time series plot to show trend more clearly. So we can do this by pandas rolling function. So for certain points in crime rate here, an average will be calculated here. So if we increase the number, the curve will be more smoothened. So here you can see that I've selected the period as 100. So you can clearly see by looking at this plot, we can clearly see that there is a similarity between time, temperatures, and crime rate. To better express this, we can do a correlation or scatter plot as we have mentioned previously. So what I just combined these two columns and created a data frame here. Now, if we plot a scatter plot here, if we clearly see that that for a certain day, I mean, like temperature for a certain day, we can exactly see what exactly the crime rate here is. So if you observe this graph, there is clearly a correlation happening here. So like if we get back to storytelling side, one thing that pops up in my eyes is there is an outlier here. So outliers are definitely leads to an interesting stories to know the reason behind this outlier. So what I have done is I've just selected the points greater than 1000 here. If you see this, this is a new year. So this is a new year again. So there might be a theft happening due to large gatherings and all. But again, this is just a 1 year. But it's also good to look at other year as well before we make a conclusion here. And also, it's good to look at other outliers and try to identify the stories behind it. Then what we have is called a linear model. So for that, what I just imported the stat model here. Then I'm giving an input as a temperature, and the output of our model would be the crime. So when I call model.fit here, we'll see the result parameters like A and B, and also the result summary shows like coefficient, standard deviation, p-value, etc. So right now I'm not digging into all this, but it's good to explore all these things. This will definitely help our model accuracy. So I'm just sticking to surface layer in this case. So if you say the weather forecast is going to be 28 Celsius this summer in Chicago, so how much crime rate can we expect? Or if the weather temperature is going to be 5 degrees, so how much crime rate can we see? So what I'm doing is I'm calling the predict function here. I'm just passing these series values. So you can see the prediction values. But again, taking such prediction will definitely grain of salt, because this is just for 1 year data. And also if you see our previous scatter plot, there is quite a lot of variance in our data. So this is to give a quick overview of how we can show a different ways. How to show a different ways that we can use our linear models here. And can we plot this? Of course, we can definitely plot a scatter plot here. So what I'm just done is I just called the AB line plot method here and just passed the model results. Then with the different matplotlib properties, so you can clearly say this is a nice graphic here which shows multiple information types, and then followed by it also shows our model on top of that, where we can also see multiple layers. So it's a nice implementation of mantra of different information dense visualization techniques. So to wrap up the things, what we have learned is we have looked at different information dense visualization techniques, and we also seen that align time series plot uh, uh, and scatter plot, which basically plots two variables on the same graph. And we have also looked at moving average method, and we have also looked at a simple linear model our data. So that's it from my end. I'm open to take questions if you have any. Thank you.